Okay, this video is going to cover section 1.4 for UMA stats, other sampling methods. So sampling methods are just ways of getting your random samples. We've talked about simple random samples already with the hat or the number chart, but now we're going to talk about some other ones. So a stratified sample takes several groups. You form a bunch of groups. Then you take a simple random sample from each group. For example, if I was down in the cafeteria, each table we might say is a strata. Strata is just the name of the group. And then we take a sample from each table or from each strata. What we want to make sure is the number from each strata needs to match the population percent. So let's say we're doing a sample of students at Monmouth Academy. So we have 4 classes, 24, 25, 26, 27. This year, 27. There are 45 students in the class of 2024. There's 53 students in the class of 2025, 49 students in the class of 2026, and 40 students in the class of 2027. If I add those up, it gives us a total of 187 students. So let's figure out the percents. Well, 45 divided by 187 is 0.24. 53 divided by 187 is 0.28. 49 divided by 187 is 0.26. And 40 divided by 187 is 0.21. Now let's say I want a sample of 50 of those students. I have enough time and money to sample 50 students, but we want the percents of our sample to match the percents of the school. If there's more juniors in the school, there should be more juniors in our sample. So we do 0.24 times 50, and we get 12 students. So we're gonna ask 12 seniors. Then we do 0.28 times 50, and we get 14. We're gonna ask 14 juniors. 0.26 times 50 is 13, and 0.21 times 40 is 10.5. So obviously we can't ask half a person. So we add these up, 12, 14, 13. We're missing 11, round up. Either way, we've got those would be the sample. So a different number in each grade representing the percent of the class. Pause the video, try this one. See if you can figure out how many you would ask of each group if we're asking 1,000 people. Lowercase n's 1,000. All right, so first we figure out our 3 groups. We have resident, non-resident, and staff. If we add them all up, we get 21,909 people. So for residents, if I do 6,204 divided by 21,909, I get 28%. 28% of 1,000 is 280. Then I do non-residents. 13,304 divided by 21,909 is 61%. And 0.61 times 1,000 is 610. And then staff was 2,401 divided by 21,909, we get 11%. Multiply that by 1,000, you get 111. So that's how many we would ask each group. All right, another way is systematic. This one does not require a frame. You don't need to know who is in the population. Instead, you're gonna ask every case individual, start with a number between 1 and K. So K is just a random number that you get. So first you figure out your population, divide it by how many you want in your sample, that's your K. Always round down because you don't want your sample to be too small. Then you pick a seed. A seed is just your starting number. It's somewhere between 1 and K. So if we go back to the school, we have 187 students. We want a sample of 20. We would do 187 divided by 20, and we get 9.35. Round down, K is 9. We're gonna ask every 9th person. Our seed has to be somewhere between 1 and 9. So I might pick 4. So I'm going to start at 4, and I'm going to ask every 9th person. So I'm going to ask the 4th person, 9 later is 13. 9 later is 22. 9 later is 31. All the way until I've gotten every student I've run into in the building, and I would have at least 20 in my sample. Pause the video and try example 2. See if you can come up with the first couple numbers that you'd ask. If we're going to say, let's say they have 1,000 customers a day and they're going to ask 30 people. I'll give you that information. All right, to find K, we would do 1,000 divided by 30, and it would give us 33.3. So we're going to use 33 for K. You pick your seed. So every person doing this may pick a different number. You could pick 10, you could pick 12, you could pick 15. So you start with that person. So we start with number 15. Add 33, then I'm going to ask the 48th person that walks through the door. Add 33, I'm going to ask the 81st person that walks through the door, on and on forever until I get to 30 people. That's systematic. A third way is cluster. So like stratified, this has groups. The groups may be similar or homogeneous. They may be different, heterogeneous. Doesn't really matter. You form a bunch of groups. Then you randomly use a simple random sample to pick a certain number of groups and then ask everyone in those groups. So with the stratified, we grouped by grade, and then we did a random sample and asked 12 people in each grade, or 12, 14, 13, whatever in each grade. If we were in the cafeteria and we said the groups were the tables, we'd ask a couple people from each table. With clusters, if we were doing the tables in the cafeteria, so first we have to choose our clusters. So if there are a cafeteria and the table, we'd number the tables. Maybe there's 15. Then we do a random sample to figure out which tables. So maybe we said table 2, table 3, and table 7. Those were the random ones that got picked. Then we'd ask every single person at those 3 tables. We wouldn't ask any of the other tables, just those 3. That's the difference. Stratified, you're going to ask a few from each. Cluster, you're going to ask all from a few. Another way to do it at a school might be to break them into classrooms. Each classroom is a cluster. Number the classrooms, and then cluster, pick classrooms, and then ask everybody in that classroom. Now, if we wanted a sample of, say, 50, and we picked 3 classrooms, and the first one had 5, the second one had 6, the third one had 10, that's only 21. So we'd have to keep picking more classrooms randomly until we end up with that N, the 50 that we want. Okay? So you look at example 3 and see if you can design how they might do that. One way is break your households in the city into neighborhoods. So each neighborhood is going to be a cluster, and you number those. Then you randomly pick the neighborhoods. Neighborhood. And then you ask everyone in the neighborhood. Maybe you break it into streets. There's lots of different ways you can break it up. The big thing you want to pay attention to is, even though your sample is random, if all of your people come from a richer community, you're not asking the other people. So you do need to pay attention to, even though you got the sample randomly, does it represent Boston? If it does, you're good. If not, you might want a different sample. Okay, we've briefly talked about convenient samples. They're just easy to get. So maybe it's like the first 20 people that walk in. Maybe you have people mail or call in. Maybe it's self-selected, like, hey, if you want to do this, come on down. Voluntary. Anything like that means you're just getting whatever's easiest, not necessarily represented. If you think about asking a question people are passionate about, people that are going to call in and answer are ones that really care either way, good or bad. If you don't really care, you're not going to call, and now your opinion's not there. So you want to pay attention to if samples were convenience. Oops, sorry. The last thing we're going to talk about is a multi-stage sample. So this is just a combination of techniques. Maybe I have a huge school. So I break it down into, I do a stratified sample by grade. And if this school has 10,000 students, each grade percentage-wise is still going to be huge. So then maybe within each grade, I have a cluster of English classes. So now it's out of the 3,000 freshmen, I'm going to look at their 50 English classes and then do a cluster sample out of the English classes. Okay, within those English classes, I'm still getting a ton of people. So then maybe within that cluster, I'm going to do another little stratified sample. And then if I do that for each grade level, I end up with a small group of freshman English and a small group of sophomore English out of the original 10,000. That's just multi-stage, breaking it down multiple times until we get a sample size we want. The hardest part about picking your sample size is you need to find a balance. The more people you ask, the more time and potentially money it takes to run the sample, but the more accurate your results are. If you ask more people, you have a higher percentage, get more results. So you have to find that balance between the reliability and accuracy of your sample and the time and money you have. Later on, we'll get into a way to do that numerically. So that is section 1.4. Let me know if you have any questions.